things I came across was this giant wooden industrial workbench. It's 4 feet wide, 9 feet long, has like this 4-inch thick maple top. You could have the entire extended family over at his house for Thanksgiving and everybody sit at one table. So I put in a bid, but not enough. I missed it. But not to worry, I said to my son, I can build one. So I don't really have to use a hand plane. I think it really is the best tool for this stage of the work. It's because I need exercise. It does my heart good, both emotionally and physically, to do some manual labor. So, a couple days has gone by. The surface has been completely planed with the number 5 Bailey, and I have finished building a 10-inch saw with which to cross cut it. I decided to cut this kind of live edge off and make it smooth, and of course we're going to cross cut right here at the narrow places between the bolts. That will be the leaf. It currently weighs something like, I don't know, 350 pounds. So by cutting it into pieces, then the biggest piece should be not more than, give or take, 150 pounds, 200 at the most. So I have it up on some 2x. I measured this distance. It's 8 3/4 from here to the edge of the blade, 8 3/4 from this cutting edge to where I want the line to be. Voila! Next, to work on the alignment pins. So one of the places you can find some raw materials is in old toner cartridges or like drum units from copy machines and printers. These are both stainless steel, fairly precision rods out of, well, one or the other, either a drum unit or a toner cartridge. They are, like I say, they're precision ground, they're in metric sizes, but as it turns out, these two are telescoping. Stainless steel, so if it gets stuff down in the crack, it's not going to rust and bind together. So I'm going to use these as the alignment dowels. Now I have the 4 end support plates built up. These are going to be slid into the pipe, attached into the end of the cross pieces of the pipe, and then they will go into the holes in the leg. Then there will be feet, adjustable feet that screw up into this hole. So the weight of the table will be on this bracket. I need to drill a hole here in the 2 ends of this pipe that's going to align with these holes. And the trick is that these holes need to be in the same plane. They need to not be twisted. It needs to be straight. If it were a square piece, you would just put it on a flat table, but it's round. So how do we make it a square that we can work with? And the answer is this bracket. We can attach this bracket to the pipe using a band clamp. So now I have it attached. So now what I will do is I will put a level on this surface and adjust the pipe in the vise until this surface is level. That will make sure that this first hole is perfectly vertical. Then I'll flip it around, re-level it, and drill this hole, and they will then be in the same plane. And then for the hole in the center of the pipe to receive the cross brace, rotate it down until this is perfectly plumb, and then the hole in the side will be exactly 90 degrees away from the holes in the ends. These will be the long frame members that will support the weight of the table long-wise. One of the pleasures of working with reclaimed materials is figuring out how to use what you got. So this piece here has actually been cut before it was discarded. So I squared it up, welded it up. It's within a 1/16 of flat over its length. Then I bolted in a reinforcing piece to make it strong at the joint. I will put in a similar reinforcing piece on this side just for consistency's sake, and because out here in the middle, of course, is the greatest force on it anyway. Then I have cut these stringers, 1-inch pipe, exactly 25 and 7/16 inches. Put them into lathe and turned them to be square on the ends. Then there is all thread through, drill through this rail, all thread down through the pipe, diagonal measure it to make sure you get the same measurement on both diagonals. That tells you it's square. So this will now be the central frame. I can now weld the various bracket pieces onto the end, knowing that I'm welding to a fundamentally square frame. So I'm just using this table surface as a big flat welding table because it's the only big flat surface I have that's big enough to do what I need to do. I have a side curtain airbag out of a car that got totaled a while back. I cut the airbag out of it because it makes a good welding blanket. Where the leg attaches to the table, we'll have a piece of angle iron to brace it. But when you bolt across here, it will just egg shape this pipe. We make a filler so that it can bolt up tight and not egg shape the pipe. And in order to increase the strength where this is going to bolt through, I have put a sleeve in it. And I'm going to rivet the sleeve at multiple points around the perimeter to lock it in place, so that as the bolt squeezes, it's clamping the whole pipe and not just one spot. And I'm using steel rivets so that I don't have dissimilar metals corrosion. Now I'm milling a flat big enough for a washer head to pull flat against the angle iron. Now I will just drill right through here into the pipe, weld a nut on the inside, and bolt right in. So it'll be bolted there, and draw this band clamp tight here, held at the top and the bottom. It'll be rock solid. This center connecting pipe is connected in here the same way as these are connected in there. Built a bracket, slides into the tube, welded it into the tube. It butts up here and bolts down tight. Okay, it's the next morning, and here is what it looks like assembled. The leg is bolted through the angle iron at the bottom and attached by this band clamp at the top. This uncut end of the angle iron runs around the outside and then is clamped tight through here. It is absolutely rock solid, as it needs to be, because this table slab is going to be pretty heavy. All 4 legs are attached. If you remove the 4 bolts, loosen up the 4 band clamps, remove the end nuts off of this center pipe, then the whole thing can be broken down for storage or transport or whatever. It's a pain, but it can be done. So here we have the underside of the table. This is the inner edge where it will join with the leaf. This is the outer edge. For the most part, I don't care about this surface under here. But when the leaf opens, this table is going to slide this direction, and this part of the underside is going to ride right on this rail. So I need to have a relatively flat surface across the area that slides on the rail. I could get out the router, but it's 5:30 a.m. and not a good time to make a lot of noise, so scrub plane it is. What is this? This is a 30mm bit, which is counterbore for this bolt and the socket to drive it. So these lag bolts, I will screw in these lag bolts down more or less flush with the surface, so that I can then use the lag bolt to level the slab against the frame. So the top slab will actually ride on 6 lag bolts. So all I have to do now is drill and screw in these lag bolts. Alright, so I've just counterbored, drilled all of these. So one thing that I like to do if I am putting in a big bolt into a small slot is grind a little bit of a flat into the edge of the lag screw, so that that spot in the lag screw will tend to cut a little bit of a thread. I'm trying to minimize outward pressure on these wood fibers. These now act as a height adjusting pad, because it will actually sit on the bolt heads on the rail instead of sit on the wood. We'll put it forwards. So here's the frame in all of its glory. That half of the slab there has been attached. It has a slider here that's hooked over the lip of that angle iron. There you can see it a little better. This one I had to put a spacer to get it up where it wasn't binding. If I had planed the bottom surface of the table to be flat, I wouldn't need spacers or whatever. But I'm just going to wing it. This is my little lock that I dreamed up. There's a piece of steel screwed here to act as a runner against the edge of the angle iron. And then 2 screws that are actually acting as a hinge, as a fulcrum point. So this piece can never move so far that the tabletop can be pulled off, but it can slide if this thumb screw is loose. But when you tighten the thumb screw, it's going to cantilever against that fulcrum and squeeze that angle iron right there. And then this slab is locked from sliding or lifting. Alright, I have finished shortening the awl thread that runs through here so that they're now down beneath the surface of the counterbore. Now we just have to plane up these edges a little bit, and then I'm ready to do a little sanding and apply a finish. So here we have the table in situ, as my Latin friends would say. This is with the leaf out. Leaf out, short table. And here we have the final form. 10 feet long, 40 inches wide, seats a maximum of 16. Probably 12 to 14 is going to be more comfortable. This is Bob signing off. Thanks for watching.